So I'll pass out part of your notes. These blue pieces of paper will be part of your notes, so I'll expect to see them in your notebook. We'll talk about them in just a couple of minutes. All right, so things to look for when you're doing this. Here's where I see people making mistakes. So I'll try to tell you what mistakes not to make. Come on. I gotta do to change pages. Space bar is supposed to work. Okay. If the cations have parentheses, the most common mistake is people think that that's the number of atoms. It is not the number of atoms. It is the charge on that atom. We can use it to figure out how many, but it is not how many there are. So, need one more? All right, good for you. Make sure you got two sides on it. Got it? I mean, here's what I'm talking about. There's somebody who's going to write, when they see thorium-2 phosphate, they're going to think there's two thoriums. That 2 does not tell me that there's two thoriums. It tells me the charge on thorium is 2, and I can figure out how many. We always have to figure out how many. Okay, the last three letters are incredibly important to look at. Look at those last three letters. Because if it ends in IDE, IDE, it's probably off the periodic table. There are two exceptions to that. We talked about those as hydroxide and cyanide. That's because you're not going to find cyan anything on the periodic table, and you're not going to find hydrox anything on the periodic table. So you can't find them on the periodic table. They're going to be on your yellow piece of paper. Got two polyatomic ions that end in ide, but the rest come off that top corner of the table. If it ends in ate or ite, it is definitely polyatomic, and you need to pull out your list to figure out which one it is. So those last three letters in any name are really important, because if you change those letters, you've changed which ion you're talking about. As you saw from the Bell work today, I hope, that I had sulfide, sulfates, and sulfite. Okay? So those last three letters are important. That's why I asked the Bell work question today. Oh, that's right, we have to watch out for those last three letters. Okay. A few people did this, so I want to make it clear. Positive piece always gets written first. Positive piece written first every time, both in the name and in the formula. Otherwise, we'd have twice as many names and twice as many formulas. And that's pretty inefficient. So the agreement is everybody's going to put the positive piece first. So that tells us occasionally we run into ones that can do both, be positive or negative, like hydrogen. Hydrogen can lose its electron and become an H+. Or it can gain an electron to look like helium and become an H-. And we saw that yesterday on the homework. When it was a positive one, we named it like a metal. Metals, we leave the names alone. Hydrogen. If it's negative, we name it like a nonmetal. Non-metals, we change the ending to IDE, so hydride. So the hydrogen ion is H with a 1 plus charge. The hydride ion is H with a 1 minus charge. So location, location, location for hydrogen. Okay, now I want to talk about these diagrams. What the heck is this thing? Okay, this is how computer programmers think. It's called a flowchart. Because when you're programming a computer, every decision is only two possibilities, yes or no. That's all computers can do. Computers can only do yes or no. Ones or zeros. So every decision it makes has to be yes or no. So I have tried to find all the decisions you have to make in order to name compounds. There are three kinds of compounds. They are ionic, molecular, and acids. Right now we are learning ionic. Right? So can I have you take your paper and put on the side with the dots down the middle? one with dots. Two sides, one has dots, the other one doesn't. One with dots should say name 1 and name 2 at the top. So that means you're starting with a name, and since we've only learned ionic, we're going to end with a formula over here. So how do you take that name and turn it into a formula? For right now, we're not going to worry about the first couple of decisions because everything we're doing is ionic. When we add another kind of compound to it, then we're going to have to make the decision about whether it's ionic or not. Is that okay? So if you look at this, the first thing it does is split. Because I've got two kinds of ions in an ionic compound, a positive piece and a negative piece. So that's what this split is about. It comes over here and it splits. The split is positive piece and negative piece. If you look down here at the bottom, what we need is X and Y. We need the charge so we can do the crisscross. Right? Because if I find that X and Y, I can do the crisscross. M for metal and M for non-metal. That's why I picked M and N. There is no element M or NM. But metal and non-metal, because metals will be first, non-metals will be second. Okay? So you actually only have to make two decisions. That's what the blank triangles are. That's a place where it splits, where there's a yes/no answer. So what your first blank should say is there a Roman numeral? Is there a Roman numeral in that name? So we're starting off with a name. If the name has a Roman numeral, the answer is yes to that question. We follow it from here, and it says we can get the charge from the name. If it says thorium-2, the charge on thorium is 2 plus. If it doesn't have a Roman numeral, if the answer to that question is no, we come over here and it says we should be able to get the charge off the table, because that means it will be in group 1A, 2A, or 3A. Because 1A is always 1 plus, 2A is always 2 plus, 3A is always 3 plus. So that's going to give me my positive charge. I'm either going to get it from a Roman numeral or off the periodic table. Now I need the negative charge. Basically, is that the name of a polyatomic ion? Because if it's the name of a polyatomic ion, you just write the name of that. It says from memory, you've got the table. You got a chart, right? You're just going to copy that right here. You don't have to do any thinking. If the answer is yes, you just write down the polyatomic ion. If the answer is no, it's not polyatomic, you're going to be able to get the charge from the table. It'll be a halogen, group 6A, or group 5A. Are we okay with that? So those are the two decisions we had to make last night when you're taking names and turning them into formulas. Once you get the charges, then you do the crisscross, and the Y ends up next to M, and the X ends up next to NM. That's our crisscross. See how that's a summary of yesterday? Okay, now flip the paper over. Okay, what it should be up top here, it got cut off, it should say X, X, and Y, Y. So capital X with little x next to it, and Y, Y. And the line comes out of X. Our decisions about what kind of chemical it is are going to be based on what the first element is. We'll make those decisions later. Okay. But for right now, once I get over there, the first thing it does is split into two pieces. Splits into two pieces because I'm going to name the metal and the non-metal. So I'm starting off with the formula I want to name. So if I find out it's ionic, the first thing I should ask myself is that first element in group 1A, 2A, or 3A? Not which one is in, it's a yes-no question. If the answer is yes, or it is in that 1A, 2A, or 3A, versus no, it is not in 1A, 2A, or 3A. If the answer is yes, all you have to do is write the name of the metal. Calcium ion. Calcium doesn't need a Roman numeral because it's in group 2A. If the answer to that is no, then you got to figure out that charge and put it in parentheses. Thorium, I had to figure out it was 2. That's how I'm going to get the first name. The first name is going to be the name of a metal. Sometimes it gets Roman numerals, sometimes it doesn't. The negative piece, once again, is it polyatomic? Do you see more than 2 capital letters in that formula? If you see more than 2 capital letters in the formula, it's polyatomic. And if it's polyatomic, just figure out what the name of it is. You just write the name of it. Hey, that's phosphate. I should call it phosphate. You don't have to worry about it. If it's not polyatomic, I'm going to change the ending to IDE. Okay? Because it's going to be off the table. So I'll change the ending to IDE. So let's work through a couple of these, using going back and forth between names and formulas, seeing how those decisions fit in. Okay? So, write formulas for these. So first I have to decide which side of the piece of paper do I want to be on. Well, what does the question ask me for? It asks me for formulas. So I want formulas at the end. Or what does it give me? It gives me names. So I want names at the beginning. So it's the one that starts off with names or the one that ends up with formula? The one with the dots. Ever see why we're using the one with the dots? Okay. So when I follow that one with the dots, the first thing it says to do is go over there, and my first decision is, does this have Roman numerals? Since it doesn't have Roman numerals, it says just write, I should be able to get the charge off the table. So I find potassium on the table. It's K. What are you doing? It's K. And K is in group 1A, so it's a 1 plus charge. The next one, is that a polyatomic ion? Sulfide, is that the name of a polyatomic ion? No, because it ends in IDE. So since the answer is no, my diagram says I should get the charge, off the table. So it's sulfide. Sulfur is in group 6A. Group 6A is 2 negative. And now my diagram says I'm supposed to, if they don't equal 0, I'm supposed to do the crisscross. So I'm going to do K2S. So see how it's all the decisions you made last night when you were doing those pieces. It's not new stuff, just a different way of looking at it. Okay. What about tin 4 bromide? Does tin have Roman numerals? Yes. So according to my diagram, it says I should get the charge from the Roman numerals. So this is tin. Tin's symbol is SN. And its charge is 4 plus, because it says 4. It says tin 4 bromide, so that 4 is the charge on tin. Bromide, is bromide polyatomic? No. So I'm going to find it on the table. Br is a halogen. Group 7A, so it's got a 1 minus charge. Do those add up to 0? Nope, so I do the crisscross, and I get SnBr4. Should be familiar. This is not new stuff, yeah. I'll look at you in a bit. Actually, I gotta wait till lunch ends, because there's a bunch of people at lunch right now. What about lithium chromate? According to our diagram, the first question is, does this have Roman numerals? No. Since the answer is no, we can get off the table. Lithium is element number 3, right in group 1A. It's an alkaline metal. It's got a 1 plus charge. Chromate. Is chromate polyatomic? Yes, so I'm going to pull out my yellow piece of paper and look up chromate. It says chromate is CrO4, and it has a 2 negative charge. Does that add up to 0? No, it doesn't. So I got to do the crisscross. So I take the 2 from chromate and put it next to lithium. And I could put the 1 from lithium next to chromate, but I'm too lazy. That's lithium chromate. extra super hard. Same stuff we've always been doing, just a different way of looking at it. Let's go the other way. Pretty quick. So what the heck is that? It's LII. It's not Lil, because Lil would have an apostrophe here, right? Actually, no, the apostrophe should be here before the L because it's taken off the T's, right? The apostrophe means you're missing letters. In don't, you put the apostrophe where the O's gone. It's do not. But it's LI. Okay, so flipping over to my other side. First decision. Is Li in group 1A, 2A, or 3A? It's a yes/no question. Yes. So it says I just write the name of the metal, and the name of the metal is lithium. And I don't put Roman numerals because I know lithium is always 1+. Second question. Is I polyatomic? No. So it says I should change the ending to ide, I-D-E. So instead of iodine, it's iodide. So that's lithium iodide. Ta-da. Almost done with lunch. One more bell. ZrCl4. Is ZR in group 1A, 2A, or 3A? Is ZR in group 1A, 2A, or 3A? No. So my chart says if it's not there, I got to put the charge there. So I know I'm going to write zirconium for ZR, and I know I'm going to need Roman numerals. Let's finish writing names first. Second name, is that second piece polyatomic? No, it's all chlorines, right? It's all one kind, so it's instead of chlorine, it's going to be chloride. Now I got to figure out the charge on zirconium. Since Cl is a halogen, it's got a 1- charge. So I got a total of 4 negatives. So I need a total of 4 positives. There's only one zirconium. So that in order to get a total of 4 positive, that one zirconium has to be 4+. And that's what goes there. It's zirconium 4 chloride. What about this one? Al2, open parentheses, SO4, close parentheses, 3. First decision. Is Al in group 1A, 2A, or 3A? So it's yes, because it's 3A. So I can just write aluminum. Second decision. Is the rest of it polyatomic? Yes. So SO4 is called sulfate, so that's what I write. So that's just aluminum sulfate. Is that right? So see how this diagram, there's really just 2 decisions. Decision on the first part, decision on the second part. Do I get Roman numerals? Don't I get Roman numerals? Do I look up charges or do they give me charges? That's the first decision. Second decision, is it polyatomic or not polyatomic? On both of them. Okay, so that's all. So what I want you to do is flip your homework paper over, and I want you to do the ones on the left-hand side. So I can wander around and check to see how you're doing on the left-hand side. I will publish